Hi students, so this lecture for BCA second sem on the statistical method. As you know, in the last class we discussed on the diagram as well as the graph, and in the last class we as well as we discussed the different types of the bar diagrams. It means what's the one dimensional bar diagram. Okay, so this one dimensional bar diagram, it includes the simple bar diagram, multiple bar diagrams, and subdivided bar diagrams, and the percentage bar diagram. Okay, so these are the one dimensional bar diagram. Okay, so it covers the first, which is the simple bar diagram. Okay, so the simple bar diagram, it covers or it involves only the one characters or one variables or one factors. Okay, it's showing only the one factors. Okay, so this is nothing but the simple bar diagram. Okay, so as you know, this diagram for the one simple bar diagram. Okay, so now see this multiple bar diagrams. So this, now see this multiple bar diagram. So this multiple diagram it means what's we, so this bar diagram, it is it means it's replaced by the multiple bar diagram. Okay, and it is used for to represent the various sets of interlinked data. Okay, so it is used for the two sets of the interlinked data. Okay, so this is about the multiple bar diagram, and it's showing like this. Okay, so there are two factors are showing in this with the help of this diagram, the company A factors and the company B factor. Okay, so next, subdivided bar diagram. Okay, so subdivided bar diagram is nothing but the components bar diagram. Okay, so this components bar diagram, and the main drawback of the simple bar diagram is what is that it can represent only one variables of the characteristics of the data, but in the components bar diagram, the various bars it means of various factors we can show in a one bar. Okay, so this is nothing but the component or the subdivided bar diagram. Okay, so next, percentage bar diagram. So whatever this data will give, this we have to convert into the percentage. It's showing the percentage bar diagram. Okay, so like this, the percentage wise we have to show the data with the help of the diagram. Okay, so now see the two-dimensional bar diagram. So now see, first of all, see what by two-dimensional bar diagrams. In two-dimensional diagrams, the magnitudes of the given observations are represented by the area of the diagram. Thus, in two-dimensional diagrams, the length as well as the width has to be considered. The most commonly used two-dimensional diagram is pie diagram. Okay, so this is the two-dimensional diagram. So it means what, you know the about the simple bar diagram or the one-dimensional bar diagram. Okay, so in this one-dimensional bar diagram or in the simple bar diagram, only the length of the bar is matter. What, the only the length of the bar is matter, but in the two-dimensional diagrams, length as well as the width is also the matter in the two-dimensional diagram. Okay, as well as this two-dimensional diagram is also known as what's the known as the area diagrams or the surface diagrams. Okay, and in such diagrams, no, both length and the width are taken into accounts, and the area generated by them is proportional to the magnitude of the data. And so this two-dimensional diagram, so these two-dimensional diagrams, it includes the rectangles diagram, squares diagram, next circle diagram, and the pie diagram. So these are the four diagrams are included in the two-dimensional diagrams. Okay, and so these all the diagrams are matter, it means the length of the bar as well as the width of the bar, it's matter in the two-dimensional diagram. Okay, so now first we will see one of that two-dimensional diagram, which is the pie diagram. So now see what in by pie diagram. So this pie diagram, this is a circle, like just like the circle we have to draw as a pie diagram. Okay, with the help of the data. So this is a circle, the sections of which represents components parts of of a whole. The method of constructing a sector diagram is to regard the whole as equal to 360 degree, the angle which is made at the center in a circle. On that basis, the share of each component is calculated and angles are made at the center corresponding to the angle of each component is nothing but the bar diagram. Okay, so this pie diagram actually it is a subdivided to represent its components. Okay, suppose if you took one factor, no, okay, so on this factor it's showing full the information. We can show the full information with the pie diagram of that factors. Okay, so it means what, it is a subdivided to represent its components, and the circle may be subdivided into sectors by subtending the angles at the center, and the total in the pie diagram, the total of the components is equal to 360 degree, and the each component is expressed in a degrees. Okay, whatever you are showing the components, no, so these components you have to show in a degrees. Okay, so the area of the sector formed by the angles and the measured by the degree of the component is proportional to the magnitude of that components. Okay, as well as so this it is distinguished between the different components as well as different shades as well as different colors are used in this pie diagram, and it is called as the pie diagrams. So because it is resembles a pie. Okay, and so you know that it is also known as the what's the angular diagram or the sector diagram. Okay, so this is about the pie diagram. So now see one of the example. So draw a pie diagram to represent the distributions of a certain blood group O among Gypsies, Indians and the Hungarians. These are the three countries are this. Okay, and the O positives group, the data is given. So blood group is O, Gypsies 343 and Indians 313, Hungarians 344. The total is what's 1000. So now this total data we have to convert into the percentage for the Gypsies, Indians and the Hungarians. Okay, so the frequency is 343 and the percentage is what's 34.3. so now how it's calculated, the 34.3, so this 343 divided by 1000 into 100, you will get the percentage is what's 34.3. Okay, so the angle is what's 34.3 into 3.60. okay, so it's equal to what's 123 is to 123.48. okay, so you have to multiply with the 3.60 means the 360 angles. Okay, it's 360 degree. Okay, so like this each and every in for the countries we have to convert the percentage data. Just we have to draw the what's the pie diagram like this. This is the pie diagram. Okay, so pie diagram showing distributions of blood group O among Gypsies, Indians and Hungarians out of the total of 1000 peoples. Okay, so like this you have to draw the what's pie diagrams. Okay, so the according to that whatever the percentage according to that it is showing in the data in this pie diagram. Okay, so thank you.